Hi, my name is Manikant Reddy, and today I want to explain the subject uh, of thevinins and nortons equivalent circuits. And my roll number is 22951 A6238. So let's go into the topic. The topic is thevinins and nortons equivalent circuit. This is uh, one of the methods to solve a circuit. Thevenins is a separate method and nortons is a separate method to solve. This is very easy. Let's introduction to Thevenin's and Norton's equivalent circuit. Thevenin's and Norton's equivalent circuits are very important concepts in electrical engineering. We will mostly used in electrical engineering only. They allow us to simplify complex circuits into simplifier equivalent circuits. Like generally, we have seen many difficult circuits like complex circuits we have seen regularly. These concepts, when we use these concepts, it became very easy to solve the circuits. These equivalent circuits help us to analyze and understand the behavior of a more complicated systems. These equivalent circuits help us to analyze and understand the behavior of more complicated systems. Okay, these are this circuit is Thevenin circuit and this circuit is Norton circuit. These are two separate methods to solve a complex circuits. Okay, right. Let's go into a topic called Thevenin's equivalent circuit. How it is solved. What is mean by Thevenin's equivalent circuit? Okay. Thevenin equivalent circuit represent a complex circuit with a single voltage source and single resistor, single series resistor. It contains only single voltage. Like we are converting many voltages into single voltage and many resistors into single series resistor, and we will solve the circuit of complex. It is formed by replacing original circuit with equivalent voltage source and series resistor. Here we are replacing the whole voltage into single voltage, like called equivalent voltage, and all resistors contained in a circuit converting into series single resistor. The voltage source is equal to open circuit voltage and the terminals of a original circuit, while the series resistor is equal to total resistor seen from the terminals with all sources turned off. Here we are looking the terminals of the Thevenins are open, and we will solve by Ohm's equation. Uh, we will get that voltage and current and resistance also will find from this Thevenin's equivalent circuit. Let's see steps to find Thevenin's equivalent circuit. First of all, determine the open circuit voltage. It's called VOC, like voltage open circuit, by removing any load connected to the terminals. Determine the equivalent resistance by turning off all independent sources and calculating resistance seen from the terminals, connecting the voltage source in the series with the equivalent resistance to form the Thevenin's equivalent circuit. Okay. Here, here first of all we open circuit wherever voltage is there, and count the resistors in the complex circuit and make it simple resistor connecting in the series connection only. This way, this is the formula to find the resistance of the uh, total total complex circuit. R equal to R2 plus R1 R3 by R1 plus R3. So here R1 and R3 are parallel, So here this is the formula R1 into R3 by R1 plus R3, and this R1 R3 equivalent circuit is connected in the series connection with R2. So uh, we may we add those two resistance. So uh, we can calculate the old resistance by this method. Next, okay. Next, what is Norton's equivalent circuit? Norton's is another method to solve the complex circuit only. First of all, here steps to find Norton equivalent circuit. First of all, we will convert the old circuit into equivalent circuit. So here I written some steps to find the Norton's equivalent circuit. So determine the short circuit current. It's called ISC by directly shorting the terminals and measuring the current. Determine the equivalent resistance by turning off all independent sources and calculating the resistance seen from the terminals. Connect the connect the current source in the parallel with equivalent resistance to form the Norton's equivalent circuit. This is simple with uh, a simple method only. This uh, all current source is connected with parallel with equivalent resistance to form Norton's equivalent resistance. This is a very best method than thevinins. Here, thevinins and Nortons equivalent circuit and similarities. Both um, we have two methods: thevinins and Nortons equivalent circuit. For, before some minutes, we discussed about thevinins and Norton's equivalent circuit. So Nortons and thevinins have some similarities. We'll see that both Thevenin and equivalent circuits provide simplified representation of complex circuit. Here we saw that Thevenin's equivalent circuit is used to convert the whole complex circuit into simple, and Norton's also whole complex circuit converting into simplified into simple ones from complex. This is the very easy method to solve complex circuits, and they have both consist of equivalent sources like voltage and current and equivalent resistance. We saw that Thevenin's equivalent circuit we call uh, equivalent resistance called RTH called Thevenin's resistance, and voltage called Thevenin voltage. It means equivalent voltage from mm, complex circuit. And we saw that RL means resistance load. And in Norton circuit, the equivalent resistor represents the load impedance seen from the terminals of the original circuit. Uh, Here are the two circuits we see. This is the one, the Thevenin's resistance and Thevenin's voltage and load here. This shows Thevenin's equivalent circuit, and here current is in towards Norton's resistance and load. This is the connection of Norton's equivalent circuit, and this is the connection of Thevenin's. Main difference is Thevenin's equivalent circuit is in series connection, and Norton's equivalent circuit is in parallel connection. That is only difference we have seen, and both similarities are Thevenin's and Norton's main main concept is converting the complex circuits into simple circuits uh, by making equivalent voltage and equivalent resistance and equivalent load. By this concept, we can solve easily circuit problems with these concepts like Thevenin's, Norton's, or anything. These are the difference. Thevenin's and Norton's equivalent circuits. Uh, some of the some of the differences are there. We'll see that the Thevenin's equivalent circuit uses a voltage source, while Norton's equivalent circuit uses a current source. This is the difference we have seen. Thevenin's is used voltage source, and Norton's equivalent sources circuit uses a current source. The Thevenin equivalent circuit is formed by connecting a voltage source in series, while the Norton equivalent circuit is formed by connecting the current source in parallel. We have seen that Thevenin equivalent circuit is formed by connecting equivalent voltages in series, uh, and uh, and with equivalent resistance. We observed in Norton's. We have seen uh, the equivalent voltage, equivalent resistance is connected in a parallel. That is the difference we have seen. Okay. uh, and next, wherever applications of a some of the limitations of Thevenin and Norton's equivalent circuits are there. It have some limitations. Thevenin's and Norton's equivalent circuits assume linearity and do not account for non-linear behavior or complex components. They are only accurate within the operating range of a original circuit. The equivalent circuits may not accurately represent the original circuit under dynamic transient conditions. Okay, here are the some limitations are there. On the right side, we have seen that Thevenin's equivalent circuit and Norton's equivalent circuit. Here, for these two circuits, we have some limitations. That is, Thevenin's and Norton's equivalent circuits assume linearity and do not account for non-linear behavior or complex components. They are only accurate within the operating range of the original circuit. They are only accurate within the operating range of a original circuit, and the equivalent circuits may not accurately represent the what they call original circuit under dynamic and transient conditions. These are the limitations, and finally, the conclusion is Thevenin's and Norton's equivalent circuits are valuable tools in the electrical engineering. These are mostly electrical students who use these two components while solving complex circuits. This is the main tool is used in while solving the complex circuits, and they simplify complex circuits and allow for easier analysis and design. Some of the uh, some of the complex circuits we have seen in electrical engineering, so we are unable to solve some complex circuits while solving. uh, it gives when we are solving the circuit, it gives a wrong values. So from by these two methods we can solve easily, by solving equivalent voltage and equivalent resistance, and We can put a load also. Understanding how to find and apply Thevenin's and Norton's equivalent circuit enhances our ability to solve practical engineering problems. Here the Norton's equivalent circuit is there. For here, okay. Let's revise the Thevenin's and Norton's equivalent circuit. First of all, we have seen that these two are useful for converting the complex circuit into a simple one for easy solving. And we have seen that in Norton's theorem, Norton's equivalent circuit, we have seen that connections are in parallel, like current and resistance and load are connected in parallel. And Thevenins, we have seen that these three components are connected in a series. This is the main difference we have seen in the both equivalent circuits. Okay, thank you so much. Tata, bye bye.